Hi guys, here we're looking at hyperbolic function and we're looking at domain and range. So let's quickly look at this just one example where we have y is equal to minus 3 all over x plus 1 plus 3. Okay, so to sketch this graph we know that our a is negative, so let's look at it just here. That's how I do it. Our a is negative, so if a is negative we know that our graph is going to be here and here. Okay, because a is negative, let's look at the asymptote. Our asymptote, we have x is equal to minus 1 and we have y is equal to 3. So let's say our y is equal to 3 is here. So let's say this is 3 and then a minus 1 is here. So we can say that is our x minus 1, our x asymptote. So the quickest thing to look at as well, let's find the intercept. So for x-intercept, let's say y is equal to 0. So if y is equal to 0, we have that x plus 1 plus 3, and then we already know that we're gonna have x plus 1 is equal to minus 3 all over minus 3. Okay, minus 3 all over minus 3. So this is basically 1, and we have x plus 1 is equal to 1, and that therefore x is equal to 0. So that is our first asymptote. And the second one, let x be 0 to find the y-intercept. So we have y is equal to minus 3 all over 1 plus 3, 1 plus 3. So that is nothing but also equal to 0. So asymptote is y. So asymptote, we have our intercept is here. Let's graph intercept here, and then we're looking at our graph. So our graph will be nothing but like this. It will be our graph. It's all intercept at x, and x is equal to 0. Then another one will be here, just like as we said that the shape will be something like that because of the asymptote and our a being minus as well. So let's quickly look at the domain where we were actually going to. That was the main point of this video, to look at the domain. So let's look at the domain. Our domain, when you're looking at domain, we're looking at the where the graph is defined on this line x here, on this line x here. So we're looking at this line x here where the graph is defined. But you see, our graph is undefined here because the graph will never touch this line here, x is equal to minus 1. So we can say that the graph is defined everywhere. So we can say that x, we can look at the graph and say that x is an element of real numbers, but x is not equal to 0. So there are many ways of writing it. You can write it like that. So x is an element of real numbers, but x is not equal to is not equal to minus 1. That is our domain is not, so the graph is not defined at x minus 1. Or someone or some people, they write it as x is an element of, they put in the minus infinite, so it's defined from minus infinite to minus 1. You see, minus 1 is not included, and also minus 1, the union minus 1 to infinite. So you can see I'm using the open bracket because minus 1 is not included, or you can use this symbol from just above here. So let's look at the range as well. So we're looking at, if you're looking at range, we're looking at y, where the graph is defined at y. So the graph is defined everywhere except at y is equal to 3. So it's the same thing. You can say we have y as an element of real numbers, but y can never be equal to 3. y can never be equal to 3. You can use the same format as the one that I used here, but this will be in terms of y not being defined at 3. So that is it about the domain. So if you're looking at the domain, you're looking at this line here, and the graph is defined everywhere, but not at but it's not defined at x is equal to -1. Just like here, if you're looking at the graph here, if our x was going to be -1, then we have -1 plus 1 is 0. So we can't have a 0 at the denominator, hence it will say it's undefined. Okay, so that was it about the undefined, or about the range and domain of the hyperbolic function. Thank you so much for watching.